Good morning, everyone. I would like to say thank you for Atmaja University for giving me a great opportunity to be a part of this event, IORA, the fifth international conference. Today, I would like to present my paper with title Evaluation Machine Learning to Increase Optimization on IT Service Management. This paper is part of my thesis program on University of Indonesia. Let me introduce myself. My name is Muhammad Agus Prihandono and Professor Riri Fitrisari is my supervisor. This section is the outline what we will discuss about this presentation progress. First, we're gonna through the introduction of the paper. Second is the methodology. Third is the result and discussion. Fourth is the conclusion. This section is introduction of this paper. We explain the background and objective. There are a lot of IT incidents that occur in an organization. The use of IT has increased in an organization in recent years. This incident need to be resolved so that the IT operation can continue. IT incident can affect or reduce the quality of IT service. The time of IT incident cannot be predicted, so an incident handling process needs to be prepared, like add employee or additional work time, and then ITSM is a framework for managing IT operations such as service IT delivery. This framework is a tool can be used for delivering a high-quality service and achieve goals for the company. This framework has a component for managing the life cycle of IT incident, namely incident management. This incident management aims to record all incidents occur and resolve business problems rapidly. Next slide is still talking about the introduction. Machine learning can predict the accuracy for resolving IT incidents. Based on the risk level above, we use machine learning to analyze and predict the accuracy of IT incidents, so the incident can be resolved immediately. And we use machine learning classify technique, SVM, and also applied optimization, namely genetic algorithm and particle swarm optimization to the classifier. We also compare two techniques above and find the best accuracy. Next, an IT stakeholder can visualize the summary and conclude the upcoming IT incident. Machine learning can read the information about IT incident fast. This information can assist IT stakeholder to conclude that in this section, we will explain our research methodology. There are three important pages shown in the flowchart. The first page is data preprocessing. First, data collection. The initial dataset has 46,606 incident records and 25 attributes. We use related attributes to the incident with a low percentage of missing value. Second, missing value imputation. We use scikit-learn method for missing data imputation. Third, evaluation feature important. Feature important is calculated using chi-square. Chi-square is a statistical test of independence to determine the dependency of variable. Next slide is about optimization method of genetic algorithm. The concept of genetic algorithm is about genetic population. Genetic of two parents through crossover mutation and selection have new crossover mutation. This is produce offspring. Then this offspring become the new population. We have an example of genetic algorithm. C have value 10, 100, and 1000, and gamma have value 0.01 and 0.1. SVM has hyperparameter C and gamma. Then we create the data based on this set of combination, and one of these combination will give the highest accuracy, which will be optimized hyperparameter. Next slide is about particle swarm optimization method. PSO simulate the social behavior of organisms, such as bird flocking. Bird flocking, they are fly together from one place to another. The initial swarm is generally created randomly. Initial swarm is depicted in Figure 1. Each particle makes use of individual memory and knowledge gained by the swarm as a whole to find the best solution. All the particles have fitness values which are evaluated by fitness function to be optimized, and have velocity which direct to the movement of the particle. During the movement, each particle adjusts its position according to its own experience and make use the best position encountered by itself and its neighbor. Adjusting best position is depicted in Figure 2. Then we get the optimum value based on this algorithm, C and gamma. Optimum value is depicted in Figure 3. Next slide is about supervector machine. The SVM is supervised learning method that analyzes data and recognizes patterns used for classification. Based on C and gamma data from genetic algorithm and particle swarm optimization, we will get the optimal value from each of these optimization algorithms. Then, this value will be used in SVM to determine the level of accuracy. Next is types of rule extraction phase. Rule extraction algorithms are used for both interpreting and mining the relationship between input and output variable in data. We use scikit-learn tree method for rule extraction. This section is the result and discussion. In the preprocessing phase, the final dataset consists of 7 attributes. There are 5 categorical and 2 numerical with 46,606 rows. Then we use scikit-learn method for missing data imputation. After that, we use chi-square for feature evaluation. Chi-square is a statistical test of independence to determine the dependency of two categorical variables. The chi-square statistic can be calculated from each of the predictor variable and the target variable. Then the existence of the relationship between them can be observed. Variable important are depicted in Figure 3. Next slide is result optimization phase. The SVM classifier was used to predict the incident priority. Two optimization algorithms, GA and PSO, were used to optimize the parameter classifier. The parameters cos and gamma were tuned for 100 iterations with 10-fold cross-validation for each iteration. The range of cos and gamma was set between 10 until 100 and 0.05 until 0.99. It is observed that the GI SVM produced the accuracy of 92.0082% using optimal value of cos and gamma as 88.98 and 0.33. PSO SVM produced the best accuracy of 92.26% using optimal value of cos and gamma as 2.068 0.06 and 0.067. Next slide is different view about the result. Based on the table 4, in the GASVM experiment, there are 5 experiments are taken. Then the best value is C 88.98 and gamma 0.331 and the accuracy result is 92%. In the PSO-SVM experiment, there are 5 experiments are taken. Then the best value is C 2.006 and gamma 0.067 and the accuracy result is 92.26%. We also plot on graph on the result of accuracy. Next slide is rule extraction page result. In this page, we visualize the weight of IT incident by providing the rule extraction. An IT stakeholder can visualize the summary information and make a conclusion for the upcoming IT incident. This slide is different view about the decision tree result. The root node contains all data from the training set. It is the top of node. Then we can see the attribute impact. This attribute impact have value less than 3.5. If match or true, then going to left side. If false, then going to the right side. This section is the conclusion. There are 2 points of the conclusion that are made. First, we conducted that some experiments which show that PSO-SVM has better accuracy compared to GA-SVM. PSO-SVM has an accuracy of 92.26%. Second, we also extract some observed rule incident to recognize the weight of the IT incident. So this is end of this presentation. I want to say thank you for watching and I apologize the mistake that are made and I hope this research will be useful for any future works. Thank you.